second one. So today we're going to be talking about USB and JavaScript. But first let me introduce myself. My name is Gergana, but I usually go by Jerry because that's a little bit easier to pronounce. And I come from South Africa. If you want to reach me, my Twitter handle is up there. I'm lucky enough to have a weird enough name to have gotten gergana.dev without having to pay a premium for it. So you can check out my website and all of the code and everything. You can get links on my website to my GitHub at the end. I work for a company called BBD Software Development. It's a consulting firm in South Africa. But I work in the research and development team. And most consulting firms don't have research and development teams, so I usually get asked what I do in the research and development team. So the plain boring answer is I do a little bit of specialized consulting, do training of the BBD developers, and a bit of research. But that's the boring answer. My team also does a lot of fun stuff. Things like building meme generators and replacing keyboards with fruit so we can play games. And my personal favorite is programming astromech droids. As you may have noticed, I really like Star Wars. And this is kind of how I got into this whole speaking thing. Because I usually don't settle for an app that just comes with a robot. I find new and innovative ways of hacking it, usually involving JavaScript. But as I said, we're going to be talking about USB. Now, USB, normal USB, USB mini, micro, USB-C, it's kind of become the de facto standard for peripherals, wired peripherals. It's used everywhere. And most of the time, USB is plug and play, right? You plug in the device into your computer, takes a couple seconds, and it works. But sometimes, the dark side of the force. You get this picture, and that loading bar does not move. It just sits there. And most of the time, you were only going to use that USB device once. So you're busy installing drivers on your computer, but you're never going to use them again. They're just going to sit there until you reinstall your operating system. Has anyone here ever had to integrate with USB devices? A few people. What languages did you use? C++? No. JavaScript? Not JavaScript. Well, I'm going to show you how to do it with JavaScript. Just wait. But usually it's not too bad, right? Because you get some sort of SDK or an API, and it's documented quite well, so you can follow the instructions because the manufacturers made it, and it works most of the time. Sometimes problems come up where the device is outdated. So you end up having to support a USB device that can only work in Windows XP with IE8 and some code that was written probably before you were born in VB6. This is a bit of a problem because, I mean, XP is no longer actively maintained. It's an outdated operating system. IE8 has a huge number of security issues which won't actually be fixed. And let's look at it this way. We can all admit that as developers, we're like magpies. We really like new, shiny technology. We don't like doing things in old technologies. So you don't really want to be maintaining that code that was written so long ago. And if you think about it, that code is usually been running in production successfully for many years, which means that you can't guarantee that making changes in that code will keep it going, and you can't guarantee that the new technology you're introducing to your client or whoever it is going to run for the next 30 years successfully. You can't give them that guarantee. Let me give you another example. So, as I said, I come from South Africa, Johannesburg, and in the part of Johannesburg that I grew up, it's really popular to, on a Friday night, go somewhere and get takeaways for dinner. Fast food, McDonald's, KFC, Burger King, or even the local canteen. And usually there's long queues out of the drive-thrus or out of the door of people wanting to get their food on a Friday night. People are hungry, they're getting angry, so they want their food. Means that the cashiers working in those stores need to be efficient. They need to work quickly to give the people what they need. Usually it's not very complex software that runs on those machines, right? It's some sort of desktop application that needs to take your order, receive payment, and print out a receipt. So the cashiers can use those pretty quickly and efficiently. Let's take this example a bit further. Say we have our Star Wars canteen. And for the purposes of this example, we are running on Windows. Now, this is usually a touch screen, so that the cashier can work quite quickly, and so that we don't need passwords. We have a fingerprint scanner, so they can log in to the machine without needing to remember a password. Makes them more efficient. They also have some sort of receipt printer to print out your receipt, and a way to take money, so a credit card machine. These things are all connected to the main computer. Let's say they're connected by USB. Now, this machine is probably running some sort of Windows desktop application using the APIs and SDKs provided by the manufacturers of these devices so that it can connect easily to them and the cashier can do their job. But now, even the small Star Wars canteen down the road needs to keep up with things, needs to keep up with technology. So one day the owner comes and says, we're upgrading to Windows 10. That's fine. We need to make some code changes, right? We need to change a few things to make it work in Windows 10. We can do it. But then, a few years down the line, the owner comes and says, we're replacing these machines with Android tablets because they're faster or more reliable or cheaper, whatever the reason is. He has his reasons. What do we do? In this case, the only option we have is to scrap the Windows desktop application we had and write a native Android API. Because the way that USB works, the way that non-standard USB devices work, is the hardware manufacturers create these SDKs and they're platform specific. So if you want to use a different SDK on a different platform, you have to rewrite. It's the only option. Or is it? JavaScript. The WebUSB API, it's a proposed web platform standard, and it's not on the standardization path yet, so it's still very new, but it's a way for building drivers for the USB devices from the browser. So they run directly natively in the browser itself, which means it will be able to run on any platform. It allows the manufacturers of the devices to build cross-platform JavaScript applications and connect and use their devices much easier than before. Now, it's based on the USB standards. And there's a number of really good references which explain how USB works, but it's very hardware intense. So if you're not from a hardware background, it's quite difficult to understand and a very, very long read. So let me give you the short version of the parts you need in order to get started hacking your USB devices with JavaScript. The first thing you need to understand with this is that it's very, very much based on JavaScript promises. So there's a lot of promises in there. You can get into callback hell if you don't pay attention to what you're doing. But with the async and await, it makes it look a lot neater and a bit easier to understand. This is pretty much all the code you need. But let's dig into it. So we have this part here, the filters. The filters are how we filter out which USB device we're looking for. We can filter by vendor ID, which is an ID assigned to the manufacturer by the USB Standards Committee. Or you can filter by product ID, which is the ID that the manufacturers assigned to each of their products. They're hexadecimal numbers, and there's different ways to find them on different operating systems. For example, on a Mac, what you do is you click on the little Apple icon, you go about this Mac, system report, and over here under hardware, there's a USB section. And this is all the USB devices. If you select one of them, oh, my servo motor's falling over, fix that later. You can see it has a product ID and a vendor ID. Now, the filters aren't necessary, so you can leave this part out, but then it will display all of the USB devices when you scan for them. And I'll show you an example of that later. The next part is the configuration. The configuration has a bunch of information about the device, mostly about how it's powered, so whether it's self-powered or whether it needs to be plugged into a USB port in order to get power, how much power it actually needs, as well as the number of interfaces. Most common USB devices only have one configuration, but there are some that have multiple, but there's only one configuration that's enabled at any point in time. So an example of a device that has multiple configurations is your phone. And that's how your phone knows whether it's plugged into your computer or into the mains directly, because a different configuration is enabled. Then we have to claim an interface. An interface is a grouping of functions that define a feature of the device. When we claim an interface, we take control of that feature of the device so that we can control it. Now, you might be thinking, how do we figure these numbers out, 1, 2? Well, the one way is if you have the data sheet of your device, you look them up in there. They are usually in there. But not all devices have open data sheets that you can find. So what you do in that case is a very scientific method. You start at 0 and you run your code. And then it gives you an error which says index out of range exception, which means you've got the wrong number. So you go to 1 and you run your code until you find the correct number. There is another way, which I'm going to show you in the demo just now, but that one is one of the more interesting ways of finding them. And then we have the transfers. The transfers are how we communicate with the device. So we send data from our computer to the USB device, and we receive data from the USB device. There are 4 types of transfers. The first one is a control transfer. And this is how we configure the device to be able to communicate with it. So we set up the device and tell it what we're going to be doing. Every interface on the device has a default endpoint of 0, and that's where all of the control transfers go to. The control transfers consist of 4 parts. The first part is the request type, and that is where we're going to be sending the information. So in our case, we're sending it to a specific class on the device, but you could be sending it to a specific vendor protocol or a USB standard. Then we have the recipient. What part of the device is receiving this instruction? So in our case, that's the interface. You could be more specific and send it to a specific endpoint, or you could be less specific and send it to the device as a whole. Then we have the request. The request is what we want the device to do. In our case, we're sending a number which says which endpoints, input and output endpoints, need to be turned on in order for us to communicate. These things are defined by the standards committee and the vendor together, and they provide them in some sort of specification of the device. Next, we have the value. The value is related to the request type. So our request type is a class, and the value that class is expecting is a number, a 1 or a 0. And then lastly, we have the index. The index is related to the recipient. So our recipient is an interface. Therefore, you can see that the index is number 2, the same as the interface we claimed higher up in the code. Next type of transfer is called an interrupt transfer. An interrupt transfer is for low latency data. So, for example, USB keyboard, when you plug that into your computer, every time you push a button, that is an interrupt transfer. Then we have bulk transfers. Bulk transfers are for large amounts of data. They allow for delays. So, for example, transferring data between a USB flash drive and your computer, that would be a bulk transfer. And the last one is a word I learned recently, so I'm not entirely sure if I'm pronouncing it correctly yet, isochronous transfers. These transfers are for streaming audio and video. So they don't guarantee data delivery, but they do guarantee the amount of time in which the data will be delivered. It's kind of weird. All right, now for the demo. I really hope the demo does not go like that. But looking at these things, it might. Stick that back on. All right, for this demo, we're going to be using an Arduino Leonardo. Why specifically a Leonardo and not one of the other boards? Well, not all of the Arduinos actually give full access to USB over through a computer. So that's why we're using this specific one. Now you might be thinking, but I already know how to program my Arduinos. I can use the Arduino IDE with C or C++, or I can even use Johnny 5 and JavaScript. But that's not the code we're writing. So this Arduino is still running some C code, which I wrote in the Arduino IDE and put onto it. But the WebUSB API is not that code. The WebUSB API is code that sits on the outside and allows you to control the device via USB, the same way you would over Bluetooth or Wi-Fi or something like that. So there is still other code running on the Arduino. Okay. What are we going to do? We're going to blink an LED. Because why are we blinking an LED? Well, when you first learn a new language, programming language, the first program you write is hello world. So when you first do something with electronics, the first thing you do is blink an LED. Blinking an LED, electronics equivalent of hello world. So that's why we're going to blink an LED. This is how our LED is connected to the Arduino. You can see it in the front here. Now, disclaimer, don't do this at home. This is not how you should connect your LEDs to your Arduino. You should have a resistor and you should connect it correctly, because otherwise your LED has the potential of blowing. Now, the reason it works is because dev boards like the Arduinos and Raspberry Pis have some built-in resistance, and they don't provide enough voltage to break the LED. But things can go wrong, so don't do it this way. Use a resistor. Important part here is that number 13 over there. That's the pin we are connecting our LED to. Need to remember that for later. Let's write some code. So over here, I have a website which consists of a style sheet, which we're not going to talk about because styles are hard. It's just to make the website a little bit pretty. We have an HTML file and a JavaScript file, which are completely empty. So let's write some code. Add some code to it. First thing we're going to do is, in our HTML file, we're going to add reference to our style sheet, reference to our JavaScript file, and 2 buttons, a connect and disconnect button. Oh no, it's doing that again. Control S is not working. In our JavaScript, we're going to get those 2 buttons, so the connect button and the disconnect button. Once we have our two buttons, we can start connecting and disconnecting. Let's define a device. This device is going to be our USB Arduino device. I'm defining it on the global scope so that we'll have access to it throughout the program. Then, when we click the connect button, we're going to add this piece of code. This should look quite familiar. It's the code we were just talking about. This vendor ID over here is the vendor ID for Arduino. So we're filtering out all the Arduinos that are plugged into this computer. Opening the device, selecting configuration, claiming an interface. And at the bottom, just showing and hiding the connect and disconnect buttons. Save that. Oh, shoot. Did I lose an Arduino? I'll get that now. Then we need to disconnect. Oops. When we click the disconnect button, we're going to disconnect. Very similar code, again, except now we're sending the value 0 to the device to tell it that we're going to stop communicating with it. All right, let's save that and check that it's working. Let me just pick up my Arduino over here. So, as I said earlier, there's already some code running on the Arduino. So when I plug the USB into my computer, the code on the Arduino is going to prompt me, because I've configured the Arduino to know that the website that it's using is localhost 8080. Which reminds me, I need to start this up. So I'm just going to use HTTP server to start it up. And when I plug in the Arduino, it pops up and says, to connect to this Arduino, go to localhost 8080. When we go there, we have our connect button. When we click connect, it scans and finds the Arduino and asks us to pair with it. We can connect. And I know it's really tiny, but over there, there's a little USB symbol. This is a kind of a security feature so that if you have a whole lot of tabs open and one of them is connected to a USB device, you can see the little symbol next to the tab, so you'll know that something is connected to one of your USB devices. And then when we disconnect, it disappears. Now, earlier I mentioned that there are other ways to find your configuration and interface. And the other way is just by logging your device after you've connected to it. So now if we go here to the console, zoom in a little bit, refresh. Now when we connect, it logs the device over there, and if we look inside, we can see the configuration. There's one configuration, and it has a number of interfaces. And the interfaces have the endpoints inside, so you can figure out the numbers like that. Okay. So now that we've connected and disconnected, let's actually blink that LED. So here we're going to add some more HTML. An input box for the pin number, and a button to turn the LED on and off. So let's get all of those things, set them up. So we have that div, which we're going to show and hide based on whether we're connected or not. Then we have the pin number, and the on-off button. So when we connect, we want to show the connected div, and when we disconnect, we want to hide it. Like that. Now, we use unsigned integer arrays to send data from our computer to the device. So I'm going to define a data array of size 3. And then, when we click the on-off button, we're going to send the data. To send the data, firstly, we're using a very fancy alert to warn people if they don't fill in a PIN number. Then, in the first part of our array, we're going to put in that PIN number. And then in the second one, we're going to add either 0 or 255 to turn the LED on or off. We're going to call transfer out to endpoint number 4 and send the data through. Just save that and check that it's working. I think my microphone's gone off. Okay, so let's click connect. There we go. So our PIN number was number 13, right? So if we hit the turn on button, our LED turns on. Hello world. Cool. All right. Now, I also have a little servo motor here, and because I really like Star Wars, I attached a lightsaber to it so that you can see when it actually moves. And we're going to make the lightsaber wave. I'm going to add some more HTML over here. Just another button to turn the servo on or off. Can you hear me at the back without the mic? It's fine. Don't worry about it. Oh, hold on. I need that. Okay. As long as they can hear me, it's fine. Cool, so we have our button. We're going to get our button at the top here. What was it called? Wave button. And we're going to use that same data array from earlier so that the LED and the... Did I push a button?
Sorry? Just continue talking.
Sorry, technical difficulties. At least it's not my code that's broken, right? Whoa. That's very loud. Can I try? Oh. Is that better? It's on? Yeah, it's on. Okay. Cool. Where were we? We got the wave button. Yes. All right. Now, when we click the button, wave button, we're going to send some more data. So I'm using the same unsigned integer array so that the LED and the servo motor can work at the same time. Let's save that. And wrong way. If we go here and refresh, takes a little while. We connect to the Arduino, make sure our LED is still working. Cool. that's pretty much all of my Arduino demos. Those are quite fun and cool and a little bit silly. But the other demo I want to show you has to do with this device that I've got right here. This is a fingerprint reader, which I got from one of the teams at work. And they've been using it for a very long time. And they were having problems with it because it only works in Windows 7. So even when I got it, I was having problems with it because I ran on a Mac and I couldn't get it to work. So I decided to try and hack it. When I started, I didn't realize how complicated fingerprint readers are. It's actually quite crazy. So I'm not actually going to show you the code because it's kind of complicated, but it's a lot of transfer in, transfer out, because you send the fingerprint reader some data to tell it to turn on. And then it sends back, OK, I've turned this feature on. Then you send it some more data to tell it to expect a finger. Then it sends back. So it's about 160 lines of JavaScript. But I can show you it working. So I've deployed this site, I'm still connected to the internet, to Firebase. It's also a very simple site, similar to what we just did, except the JavaScript file is a little bit longer. You can see I even used the same style sheet. I'm going to plug this in. Unplug the Arduino. When I hit connect here, you see on this one, I didn't add any filters, so you can see a whole bunch of devices over there. That's the correct one. I can connect to it. When I push scan, the light on the fingerprint reader turns on. I can put my finger on it. Reads my fingerprint. Now this is cool, but I have something cooler to show you. So over here, this is my phone being mirrored. OK. Now I'm going to go on my phone and go to that same website. Zoom in a little bit so you can see. Same fingerprint reader, plugging it into the USB on my phone. Going to hit connect. Scans and finds the only USB device. So you can see Android has a few extra security features. So it prompts me again, are you sure you want to allow this website to connect to your USB device? I say yes. If I hit scan, put my finger on the fingerprint reader, we have a fingerprint. Now, I think that's pretty cool. It's the same code running on an Android device and on a Mac. Now, next bit. You're probably thinking, how safe is this? And if you're not thinking it, you should be, because it's kind of scary. But as I said, it's a very new API. It's still in development. And they are doing things to make sure that it will be safe. Firstly, it's only HTTPS, which means that at least the data is encrypted. Then we require user interaction in order to initiate the scan for USB devices. So we need to click a button, and you can't fake it. You can't do a JavaScript in JavaScript just say .click. It knows you're doing it, and it blocks you from doing it. Then we also need a user permission. So you saw on Android it was a lot more explicit about the user permission. It asked you, are you sure? On Mac, it doesn't ask you again, but it's still there. You can also use a feature policy to control whether WebUSB is allowed or not. So setting it inside an HTTP header, or if it's running in an iframe, you can use the allow attribute to prevent USB devices from connecting. Currently, there's also no support for human interface devices. The reason for that is because that way, if you could take control of someone's keyboard from a website, you could put some sort of keylogger on the keyboard and do dodgy things. Now, I first thought that a fingerprint reader was a human interface device, but apparently this one isn't considered one. So luckily enough, I could use it for this demo. And then this last one, which is one someone else pointed out to me recently, is that you can only connect to a USB device once, which means that if from one tab I'm connected to the fingerprint reader, another browser tab can't get access to it. And then there's the question of support. Well, we saw it running in Chrome. It is a team at Chrome that's doing this WebUSB thing, so they're the ones pushing for it. Then, not that anyone really uses Opera, but it works there. And then the Edge one is actually a lot more this way, a lot closer to the yes side, because the beta version is already based off Chromium, so as soon as it's based off Chromium, it will be possible. Firefox is undecided on the topic. Firefox tends to support things that are on the standardization path or that are going to be web standards, and because this is not on the standardization path yet, they haven't made up their mind as to whether they want to support it or not. And lastly, Safari is the problem child. They have said no, just no. They're not even considering it. So, yeah. For now, there won't be any USB access on iOS. That's it. That QR code there is for your feedback. I'd appreciate feedback. And are there any questions? Yeah.
I'm looking at your code, right? There's a navigator object.
Yeah.
How come it's usable suddenly? How did it happen?
Sorry?
The navigator object in your code.
Yeah.
When was it injected, or when was it created? How is it created?
It's part of the. It's not. It's a thing in the platform where you can access it from the browser. It's part of the browser.
Okay. But from there, you can access that USB. Right?
Yep. Yeah. So I need to close that. Sorry, frozen. Yeah.
Yeah, that part.
Navigator is the browser.
Yeah. Okay. So it injects the USB object.
I'm not sure.
How come you can code suddenly and talk to the device?
It's a platform feature. It's a WebUSB is a browser platform feature. It's part of the browser.
Oh, okay. It's a part of the browser. Oh.
Yeah.
All right. That's part of it.
Okay. Yeah.
Can you remember the USB has been connected and you don't have, is there a way basically to not ask the user every time you connect?
So no, when you close your browser and reopen it, it asks for permission again. It forgets. Yeah. Yeah. As far as I know, there isn't a way. And I think that might be because of the security issues. Yeah?
You said HTTPS only.
Yeah.
Does that apply to localhost?
No, it does not apply. So it's HTTPS only. It does not apply to localhost when you're developing. Yeah. Sorry. Any other questions? All right. Well, thank you. Don't forget to feedback.